Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Advancing Connectivity in Underwater Sensor Networks through Triangulation and Optimization-Based Hole Detection and Mitigation. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the recent research area, that is underwater sensor network communication. So, underwater sensor network communication is very unique topic, and it is one of the technology in which very rare researchers are working on. But underwater communication is still a challenge. So in order to handle that, we are proposing one of the methodology where the holes, those are detected under the sensor network under the water, are initially detected and then mitigated. So how we did that? Before starting that, let's talk about that what we will cover into this video. In this video, initially we will talk about in which application areas this hole detection and mitigation can be implemented, especially for the underwater. Then the code that we have designed, how to execute it, what software requirements are there for it. Later on we will discuss about what are the current technologies available for the same scenarios, what are the problems identified in them, and finally what proposed system is doing and what new novelty is done in the proposed method. Finally, the overall experimental outcomes and the findings will be done. So initially when we talk about the application areas, so especially it is for the underwater wireless communication. So that can be specifically for the ship stations, for the security purpose, for the military stations. So there are certain application areas in which it can be implemented. So you can see one of the example that how underwater communication has been done, where the below the ground the communication is being performed by the ship. So underwater wireless communication is for specifically for the defense people, because underwater communication is basically used by the ships, submarines, and a higher level of the devices at the national level. So it can be implemented for monitoring, for coastline protection, for the disaster protection, for the military purposes like for mine surveillance, enemy movement detection, disasters like flooding, oil spill, because the oils are transferred from one location to another through the underwater pipes. So other than that, monitoring like exploration, natural resources, pollution detection, water quality. So these are the applications of the underwater wireless sensor networks, because the sensors are placed on the different locations in order to perform the communication and to surveillance or remotely access those data. Now the challenge is like sometimes because it is underwater, it is not easy to replace the sensors on the regular basis, or not easy to check the performance of the sensors, that whether it is working or not on the daily basis. So in order to remove that, an automated system can be designed by getting the signals from these sensors and can brought the information that where the holes have been detected, so that in place where the sensors stop working or something, the new placements of the things or the sensors can be done easily only by knowing it at the remote location. So inspired from this, we are working on this unique topic. Now let's see what the code is. So we do have the code this. So we will give you the folder name code under which there are number of the files with you. The whole code is implemented in the MATLAB, so you must have the MATLAB software 2015, 18 or 19. That will be perfect for running the code, but make sure the MATLAB version that you are using must be greater than or equal to 2015 version, and the full version, not the trial one, because trial one is restricted with certain libraries, right? So to run the code, you just need to copy the path of the folder where the code is placed, and then go to the MATLAB and paste it here. When you place it here and press enter, the all codes will be shown here. You have three files to run. One is for the detection, second for the analytical of the detection, thirdly for the whole coverage. So to run the code, you just need to click on the main code detection, run. When you will click on the run, it will start processing. As you can see, I'm just clicking on the run button, it will start processing and will show the results. In the meantime, let's talk about that, what exactly the current systems are doing and what novelty is there in our proposed system. So this is something representation of the proposed work, so I'll discuss it later on after discussing the problem. Currently many of the papers are working on the hole detection. So basically underwater hole detection is a rare domain, so many rare papers will be found. So we just take the references for the wireless sensor networks in order to understand that what kind of strategies people are using. So they are using like K-hole coverage, hole detection. So most of the people are working on detecting the holes only. Very rare studies are available, those are providing the solutions after detection of the hole. So one of the base paper that we were following, this is for detection of the hole by using the K coverage. One of the paper that we were following for detecting and mirroring the holes, in which they have implemented NS2 simulator and WHD algorithm. WHD algorithms gives you which is basically wireless sensor hole detection algorithm, is termed as VHD. So they were detecting the holes and then showing the results in terms of parameters like average energy consumption and this. So inspired from that, because the area was very unique, so we found very rare studies in this particular domain. So this process need to be automated. Secondly, this process must have the strategy that is effective in comparison to the existing hole detection methods. So one of the hole detection method that we explored was triangularization method, but it was having the limitation that the triangularization based method is finding the holes in an effective way, but it is also reviewing the data which is outside the network, which gives us, because triangularization, sometimes you can see, for example, I'm showing you in the paint. Let's see, we do have a network and the nodes are mostly located at this places. So the triangularization method, what will do, it will make a triangle and will cover the area which is not even in the region which is to be reviewed. So the extra resources and extra holes can be detected, and that can lead to the bogus information for placing the new nodes. So inspired from this, we have proposed one of the method which basically works on region of interest based uh, holes detection. Secondly, in order to cover those holes, we are proposing the recent technology in which optimization based algorithms has been implemented to cover the hole. So optimization algorithms are the domain which can be used in the areas where we need to find the certain solutions. So these are the type of the algorithm to find the best solution of any of the problems. So we are applying it in our proposed method. So one of the novelty that we have done in our method is like we are proposing the optimization algorithms to solve the holes issue. Secondly, we are proposing a new optimization algorithm in order to show the novelty in the algorithm level basis also. So we have implemented PSO, then we have implemented TSA. So you can see here we have implemented one of the algorithm that was PSO. Here is the PSO. Second, we have implemented the TSA, and thirdly, we have proposed a variant for TSA, a modified TSA, MTSA. So this is what we implemented in the proposed scenario. So let's see how it works and what exactly it is done. So initially we have proposed the hole detection methodology using the region of interest and triangularization. So this is the code 1 in which the hole detection methodology has been implemented and demonstrated. So when we are running this code, you can see it will show us certain results where taking a specific area, number of nodes has been plotted, then on that behalf we are detecting the holes. So you can see these are the graphs. So let's discuss about the outcomes. So this was the initial network which we need to identify that where it is holes. The holes are like this. Let's say an example. This is the area where there is no node. So might be this can be the crucial area where the communication can be degraded. So by applying the normal knowledge triangularization method, we made the triangulars by the basic triangularization method. Then we have detected the holes marked in the black color within that area. So you can see in certain regions here, like this black point and this black point, it is not required because no, the nodes those are covering the area is inside that particular region. So these are the additional services that will be required in order to handle the holes, and the count of the holes will be more. See here, one more hole is there. So then we have applied the region of interest based method, in which we have removed those holes those were outside the boundary. So you can see here the boundary get restricted, right? Those holes has been skipped. So this is the advancement of our proposed method. Then we marked those as a red color. This is how the holes are being detected, our proposed methodology. So this code only shows that how the proposed methodology is working on the region based knowledge triangularization method. Now it was the time to analyze that what exactly it is doing, by how much energy consumption is saving, and what is the detection rate, what will happen if the nodes will be increased. So this is the second section where the analysis of the detection has been done by varying the nodes, by checking the time for the detection and the count, right? So we need to run this code. We just need to click on the run button. So in this scenario, we just detecting the holes and plotting the holes. For number of rounds, we have use the energy model, where the energy communication has been used when the energy is being depleting, and on that behalf, if node get depleted, node will not be able to communicate further. In that scenario, a hole will be created over there. Then we are seeing that how efficient our proposed system is in detecting the hole and marking it as a hole. So this is the scenario. These are the graphs. Here you can see this is the initial network which we have implemented. This is the holes detected in the black mark. Here you can see they are refined after implementing the proposed method. Then finally, in every iterations, the energy depletion is happening because the communication among the nodes and the sink is being done, because it is a heterogeneous network. So in every of the round, as you can see in the bottom section, in every of the round the communication is being processed, and the nodes those are releasing their energy and getting dead, that particular area is marked as an area without the node. Then in every round our proposed method is detecting the holes. So it will take few seconds to complete the whole scenario in order to show the outcomes. Then we will do the analytical part in the result section, that how and how much time it is taking by changing the nodes and the area and the communication rounds. So we need to wait for the simulation to get completed, because it is a round wise simulation. So it is just taking the quick view over here. So we just need to wait for the rounds. So it is still running, because every round more the nodes get dead, more the time it need to detect, because the holes are getting increased. So combining the uh, improving the MTSA from the TSA and PSO. We just got motivated from the paper, that one of the paper where hybridization of PSO and WA has been implemented, that shows that hybridizing the existing method, those are having different abilities, can provide us the better solution. So inspired from this, they have even evaluated it and shows that the combination of the methods can prove the better effectiveness in the systems. So inspired from this, we have modified the TSA algorithm. So the TSA is basically TSA optimization algorithm. So the algorithm is, there are different names given to the TSA. One is tree seed, another one is truncate swarm optimization. So we are using tunicate swarm optimization. So we are proposing that in our scenario. So code is running and we need to wait for all the rounds. Let's see how many rounds we have mentioned. So number of communication rounds are around 500, or it will run till when all the nodes get dead. I think it will run for all the rounds. So let it skip few of the rounds. So here you can see all the rounds has been completed. So results will be demonstrated here in few seconds. So now let's review it. This is the network structure. This was the hole detected. This was the refined heterogeneous network with the holes. This is every time the holes, those were identified during the simulation, well, when all the nodes are communicating and depleting with the energy, and finally after 500 rounds 3 of the nodes are pending with the energy, rest all nodes get dead, and all those black marks shows as a holes in the network after depletion of the energy. So this graph shows that's how energy get depleted with change, with the increase in the round of the communication of the different nodes. So this is the detection time of the holes in every round. So you can see the count of the detections has been shown on the x-axis, and how much time it does take to detect those detections has been shown. This is the graph of number of the holes with respect to the round. So you can see initially it was less. As the rounds increases, the communication, oh sorry, the hole count get increased, because the normal nodes were also getting dead and creating the holes in the network. This is finally the detection time while changing as the count of the nodes get increases, and it shows that by getting the nodes increased in the hole, the detection time also increased, because obviously that much rounds it need to process. So this was the analysis of the detection of the holes in the realistic network with the energy model that is used by the communication. So after this, whole coverage has been done, in which this is the code where the similar scenario has been taken, where initially we are detecting the holes. Then by using the PSO, we are finding the we are adding new nodes. So the objective is to add minimum nodes and covering maximum holes. So inspired from this strategy, we have applied to cover the holes. So you can see here PSO has been implemented. Then we have seen that in before applying it, we have calculated that how many holes are there. After applying the PSO, we have calculated how many holes are there, so that we can show that how many holes has been covered by this. Similarly, it is done with the TSA, then it is done with the proposed MTSA. So let's run this code. You can see the simulation and also the results. So when I'm running this code, you can see it is running for different iterations for the PSO, TSA and modified TSA. So 3 times iterations of 100 rounds is being processed, and the results will be shown in the graphical form. So you can see these are the outcomes that we found. This was the network, these were the holes detected, this is the holes healed by the PSO, these are the holes healed by the TSA, and these are the holes healed by the MTSA. Finally, the convergence curve of all the methods has been shown. So you can see the convergence curve of the proposed method MTSA is better in comparison to normal TSA and the PSO. So it means our system is more efficient in achieving the fitness that we were trying to achieve. In final results, how many holes has been covered with the different algorithms? Without healing, it was around 40. Then PSO was healing it good. TSA individual was not that good in healing the heels, but MTSA is getting the better results in comparison to the PSO and TSA itself. So as many times we will run the code, the convergence curve shows that the fitness achieved by the proposed method is better. It means it is achieving the coverage of the more holes. So this is the strategy that we have implemented for the proposed methodology to detect the holes as well as to mitigate the holes. In the proposed MTSA method, we have hybridized it with the strategy of getting the new solutions by the TSA as well as by adding the concept of, you can see, modified TSA. So PSO's concept has been implemented to it, so get the ability of both the methods for the better results. So this affects the performance and gives the better results in comparison with the traditional method. So further modifications are still possible because this is very unique topic and it is hard to identify and implement in the real world. The recent researches can further be extended to the same domain for the underwater communication. That can be an unique topic and unique area of the research. So for such videos and such topics in the future also, stay tuned to our channel. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.